ప్లాంటర్తో విత్తనం వేయించి వేసాం సార్ ఆ మధ్యలో. దానికోసం అది నెక్స్ట్ డేస్ ఆగస్ట్ సార్ 4 months తర్వాత కూడా డ్రై సైడ్ సార్ ఇదంతా. అంటే మీరు మధ్యలో చూస్తే కదా ఆ ఖాళీ వాళ్ళు ఉన్నది ఉంది సార్. మనం ఇంటర్ క్రాప్ ఏమైతే ఆముదం అనేసినా ఉంటాయి చూడండి సార్, అది సీ ట్రీట్మెంట్ అదంతా వాళ్ళు డ్రై సైడ్ కోసం సార్. నెక్స్ట్ ఆ గ్యాప్స్ లో అదే ప్లాంటర్ తో సార్, ఏడ్ నుండి చేసిన ప్లాంటర్ తో విత్తనం వేసాం సార్. అది మల్చింగ్ అది 2 రోజులకు ఒకసారి పిచికా చేసాం. నెక్స్ట్ ఒక 3 times అప్పుడు వేసినప్పుడు అప్పుడప్పుడు వచ్చినాం సూపర్. నెక్స్ట్ అది ఏంటనేది స్టార్టింగ్ నుండి చేస్తాం వాళ్ళకి కదా సార్. జనరేషన్ సెకండ్ ప్యాచెస్. నెక్స్ట్ అదే సార్ అవన్నీ ఆ ప్యాచ్ లో వచ్చింది సార్. నెక్స్ట్ సూర్యమండల ఆకృతి అది వేసాం సార్. అది బ్యాక్గ్రౌండ్ ఉంది, అది మీరే చెప్పండి సార్. సూర్యమండలం అంటే ఇంటి దగ్గర ఒకటి మోడల్ అక్కడే వేస్తూ ప్రతి ఇంటి దగ్గర వేసుకున్నారు సార్.
సూర్యమండలం. This is for raising for 15 to 20 vegetable crops near their house.
అది గంగమ్మ బాత్రూమ్ అంటారండి సార్ మహారాష్ట్రలో. నెక్స్ట్ ఇప్పుడు కొత్త వచ్చి ఒక 8 క్వింటాలు వచ్చాయి సార్. మధ్యలో ఇంటర్ క్రాప్ అంతా కూడా అలాగే ఉంది సార్. అవును సార్, అది బీడీపీలో ఉన్నా అక్కడే. ఓకే సార్.
She has combined the very excellent model of social equity and taking their skills, not their weakness, their strength in farm work into a operation. Thank you, Pandra, and I hope by next year all the women in that village will join you. 100 acres. Good. That's the right kind of target. No? Okay, I now invite Anne-Sophie, and I must inform everyone that she is the one responsible for this whole program, and request her to talk on scaling up of agroecology at international.
Both? The PowerPoints. Both?
No, it's only one. This one. So, yesterday we went to the field and to different villages and visited a number of farmers, and of course Anantapur right now is extremely green. This is probably the greenest time of the year, and it doesn't give Jehne and Walter, I think, the picture playing in a very strong, almost dramatic terms in the evolution that we've seen in the past 50 years in Anantapur is happening in so many around the world. And climate change is only making things more dramatic. Now, 1% in temperature increase will mean that 500 million extra people would face scarcity. So for every 1 degree, that's another 500 million people. That's it. And water is bound to be one of the major crises facing us. But of course, global change and climate have multiple impacts that we see on other things, and not. But water, I'm talking about water because Walter will come back to that. This is really a critical issue. How do I go next?
Just say next.
Yeah, okay.
Okay, so at the same time, one person out of 7, that's about 1 billion people is going hungry. So that's really almost the population of India, 1 billion people. So we see that the food system globally. What is the food system? The food system is all the activities around food and agriculture, from production of inputs to producing food and feed and fiber to transforming it, transporting it, selling it. So you'll excuse
Ah,
that.
anda
very
na aర్థం కాలే. ఈ
complicated
పక్క
graph.
చూడడం అర్థం కాలే.
That's word from my colleague from Sirada, Bruno Dorian, with whom we're working in Andhra Pradesh on scenarios of how to deal with this on the bigger picture of things, on the food systems. So what you see in the blue circle on the top right is the very, very small weight of agriculture
కేబుల్
in
కనెక్ట్
OECD
కేబుల్
countries.
కనెక్ట్ తీసాను.
It's about 3% of workforce of employment, and it's 3% of GDP. In OECD countries, that's how small agriculture is in the economy. So, agriculture is not the main pillar of the economy in most of the OECD countries. Now, and you see the other regions. You see the green SSA at the bottom is Sub-Saharan Africa agriculture in the future. That would be enormous urbanization for these people to move to industry and services in the cities that we've never seen on the scale of humanity, such the urbanization that would be needed for this. We also see that we have in India essentially a jobless growth. Industry and services are not creating enough jobs to absorb all this workforce. And we see the distress of many people moving from rural areas in strenuous jobs in agriculture to work in construction. Is that better? It's still strenuous, it's poorly paid, and people mostly have construction workers in cities live in slums. And that's why we see also young people preferring to stay in rural areas, except that rural areas don't offer many opportunities. So we need to reverse this model of thinking that all the workforce is going to go to industry and services, because it's not happening, and it's unlikely it will happen. Even the IT miracle, and Andhra Pradesh is one of these examples of, the IT miracle. I think it's about 7 million jobs globally. 7 million. It's very small. So yes, we need to move to high-skilled jobs, but that's not solving the problem of the employment and incomes in rural areas. So actually, why are jobs not created enough in industry and services is because they are mechanized. They're machinery, which was not the case when our OECD countries industrialized. We're not industry now. Services are computerized and mechanized, whereas when OECD countries transitioned away from agriculture, that didn't exist. And unskilled workers from rural areas were moving to unskilled jobs in industry. So that was much easier somehow for us to industrialize. But the game is different for other countries now. So what more economists now are starting to say is we need to bring value back into agriculture. We need to keep people in a better agriculture and in creating jobs in rural areas and creating value addition, ecotourism, jobs on farms from processing on farms or in rural areas, from processing, from cultural value of people coming back to farms to visit farms, etc., etc. Next. So this is the dream, right, for many farmers. So sitting on your tractor, having endless, huge hundreds of hectares of one monoculture. Now, and today it still is, right? I mean, farmers they want mechanization, they want to sit on the big tractor. This is what it is to be modern. Now, what we are seeing is that in the US and in Europe, the category of workers that is most likely to commit suicide is farmers. And they have this. And they are hugely indebted on these machineries. And it's a drama. Farmers are strangled by debt for having huge land, needing huge machinery that are very expensive to maintain. So, and in India, you don't have huge land, you have huge population and scarce land. Okay? We have about 17% of population for 3% of arable land. So where are the people going to go if you want this? If you want hundreds of hectares of farms? Into slums in the city? I spent 2 years in Delhi, and today, even in Delhi, you cannot breathe. So what is the model? Yes, exactly. So we need to invent a different modernity for agriculture, and we need to revalue the services that agriculture provides to society, where farmers are not in the lower end of the social scale, which is often where farmers feel, but they are not considered. But as one of my friends, an organic farmer here in India, says, you need your lawyer not very often, maybe once a year, maybe never, maybe once in your life. You need your doctor maybe twice a year. How many times a day do you need your farmers? 3 times a day? Right? So we need to value this, and society is starting to revalue farming. Yes. So what now? Scientists are starting to say at the FAO, we are the global agency of the United Nations for Food and Agriculture, and there's a lot of debate, believe me, in our governing bodies about where are we going with this. We have a highly sophisticated, industrialized food system with supermarkets and cold chains, and we are not feeding the planet, and we are wasting the food, and we are depleting our ecosystems beyond repair. So here you see subsistence agriculture on the left, which was also having its pitfalls of low productivity and keeping people in poverty. And on the right you see the industrial agriculture model, but we've seen its limits also. So what scientists are now saying is that both of them need to converge towards more diversified systems, which means where the subsistence agriculture needs to upgrade in building more skills of farmers so they can farm better. Also connecting them to markets and helping them to diversify. We saw the dramatic picture that Maladi presented of less and less diversity in Anantapur. And now we realize this was wrong. This ecological sort of specialization is not natural. I'm going to ask you a question. Have you ever seen monoculture anywhere in nature? You walk around the forest, you walk around the field, anywhere, in your garden. Have you seen monoculture anywhere? No. So this is extraordinarily artificial. Okay? So for some decades, we've had a model where we thought that this was the best thing to do. And generally people felt, let's specialize the areas of land and produce a lot of one thing. Lots of wheat or lots of rice in the territory, because it's more efficient. Now what we're realizing now is that both from the scientific, agronomic, environmental, ecological science, this is not making a lot of sense because it's too artificial. We can't maintain it. We need too much fertilizer, too much pesticides. We are promoting more pests and disease outbreaks because there's uniformity, and pests and disease love that. They thrive on uniformity, whereas the pest and disease decrease in diversity, because you have so many mechanisms, smart mechanisms of nature to keep the pressure down, right? So the cost of this monoculture model is very high, but not only from a scientific, environmental point of view and agronomic point of view is it questioned, but also from the economic point of view, because it's very risky for farmers to have only one thing, and they depend on big buyers then, who want a lot of one thing. So let me tell you, just before I move on, a story of my country in France, which in 2014 passed a law on agroecology, thinking we need to reverse this trend, we need more diversification. Now the big challenge for France is what? Is that the structure of the value chain to whom farmers sell are geared to buy one thing. So if you're a wheat farmer south of Paris, in the large plains where we're doing lots of cereals, you're doing one variety of wheat, and your mills, your buyers, they want one variety. And then they will do their mix to make flours. They don't want to buy 3-4 varieties and pulses and tomatoes and whatnot. They want one thing. So it's very hard, it's proven very hard for farmers to diversify because of the markets, right? So that's why we say that we need a change in the food systems, because farmers wanted to diversify, they couldn't. Where am I going to sell this? So the great chance you have in India is that you don't yet have structure of the economy with huge farms, monocultures, and few buyers who can absorb big quantities and then who dictate the prices. Because if you have thousands of tons of wheat, who are you going to sell to? Not local consumers, obviously. So then you're at the mercy of the few people who can buy this. So in India, you still have local markets. You have a few places that are highly specialized, some of the states and some of the cropping systems, but it's not the majority. Okay? So I think there's a lot that you can build on to also rebuild local markets where consumers, a housewife, she wants a diversity of products. She doesn't want just one. So if you sell to them directly, as farmers, you have a much better option to sell multiplicity of things that grow on your field and have a diversified system that will keep your input costs down and will be more resilient. You've seen the fields after the cyclones in the coastal areas of Anga, where ZPF tends to fare better than conventional systems because the root systems are stronger and the crops are more resilient. So in FAO, we promote these approaches called agroecology. Agroecology is a family of approaches, and we consider that natural farming, the way it is practiced in Andhra Pradesh, is a form of agroecology. But you could say many forms of organic agriculture, or permaculture, or conservation agriculture, or other families are also part of that. And we think we need to promote any farming that is based on farming with nature. So it is basically applying ecological science. What does that mean? That means understanding how nature works. Applying this to how you farm. Farming with nature's mechanisms rather than farming artificially bringing inputs from outside to support the system. So basically it focuses on improving interactions between different plants and animals, microorganisms, etc. So this is what is happening in natural farming here, where you have this 5-layer models, for instance, that were presented earlier, but also where you have a strong emphasis on soil health, regenerating the mechanisms of soil health so we can nurture plants, animals, humans. Okay? And then agroecology has also become a broader concept of tackling the food system. Not just the production, but these other aspects that I was mentioning earlier about how the system is structured. We'll go to the next. So this is 10 elements of agroecology. I don't have the time to go into all of them, but you can see diversity is a big pillar, and you see this as a core element of natural farming. Synergies between species, between plants and animals, for instance, between trees and plants, etc. Co-creation and sharing of knowledge. This is critical. And if you give me the next slide. Yeah, next. Yeah. So we think that in order to change systems, change implies doing something differently. And that means innovation. We are not going to get out of the food system crisis we are now, and the ecological crisis, by doing more of the same thing. We need to do things differently. And that implies a collective process of innovation. So innovation, we often think it's a technology. But if you think of innovation, you think, oh, it's drip irrigation, or it's a high-yielding variety, or it's something you can sell, it's something you can hold in your hand. Actually, innovations more and more is thought by the literature, the scientific literature, as a collective process of different people working together, and it's also institutional innovation. The self-help group is a wonderful institutional innovation. You can say farmer field schools is an institutional innovation. And if we want to transition to more sustainable, resilient systems, we need to have these institutional innovations. So what I want to say is that Andhra Pradesh is not an isolated case. You probably feel sometimes as grassroots workers, practitioners, and managers that the system is doing something completely different in India. And it's true. But what I want to say is that many people around the world are trying to do the same, and are doing the same successfully in many countries. Mexico is a country that has passed a law that all their agriculture would be agroecological. That was just very recently. More and more countries are trying things. So we need to persevere and promote different forms of agroecology and work on how do we get us to more and more farmers. Right? We go back to the slide. So FAO was created and facilitating a global scaling up agroecology initiative to support countries and have a concerted action framework with many UN agencies and countries and OECD, Europe, etc. And it's a few weeks ago, middle of October, VJ was in Rome addressing the Global World Committee on Food Security. It is the committee of all the member countries of the United Nations, all the countries on the planet, gather to discuss how we feed the planet and how do we do that sustainably. And VJ was invited to address this committee and talk about the activities here in natural farming and agriculture. And that was really very interesting. And actually, Andhra Pradesh is one of the 3 pilot initiatives that the Scaling Up Agroecology Initiative has chosen to support and to give more visibility to. Because it's one of the biggest initiatives of agroecology globally. And the member states of FAO, a report was presented to them on agroecology in that instance, and they gave wide support. So don't think that what you're doing is farming like your grandparents. As I was saying yesterday in the farm fields, you're farming like your grandchildren. You're farming like more and more people will try to do in the future. And there's a lot of science backing this. So there's a few policy recommendations. Next. I'll skip some of the examples. This is Bolivia, this is Benin. We have many examples next around the world. So go back one slide. So one of the policy recommendations that countries have agreed to in multiple FAO fora and workshops in the past 5 years on agroecology around the world in all regions, one of them is to promote interactive learning and farmer innovations. Farmer innovations are legitimate. And it's not, innovation doesn't just come from a lab or from a research station. Innovation comes from farming, and it has for centuries and thousands of years. Next. We need also more public research for agroecology. Sometimes people say the yields are low, this and that, but very few, maybe only 5%, I think the estimate is 5% of research, agronomic research globally goes to agroecological approaches. It's very minimal. So of course, this is not a level playing field with conventional farmers, chemical farming, right? Because we don't invest enough in the research. We need also policy and regulatory frameworks. We need smart incentives. I think 70,000 crore fertilizer subsidy every year is what India spends. It's about $12 billion on just fertilizer subsidies. Where are the subsidies for ecological farmers? They don't exist in India, by and large. Okay? So again, the competition is unfair, right? So we need policymakers to invest in the future of agriculture, right? And pass laws and support programs. And we need also to support communication and trust relationships between farmers, consumers, and intermediaries. Because a lot of consumers have become detached, especially in the cities, from how their food is grown. It's maybe not the case in rural areas. But we need to bring this back and bring consumers back onto farms and citizens back onto farms to see the beauty of this farming. And it's only going to happen on ecological farms. In Europe, in the US, you have a lot of ecotourism. People don't want to see a farm where they're going to be poisoned by pesticides. They want to go on a farm where you have actually animals to show to their children, where you have a diversity of crops and a beautiful scenery, and that is healthy. So there's a lot of potential on tourism in rural areas, on small-scale processing, on promotion of local products, etc. So I won't go much further, and I think what's really exciting is that we have here Walter and Didi, who are going to give another side of the big picture. This is more the big picture from the food systems and the markets and the scenarios for agriculture. Now, all of this, the underpinning of all of this is our natural system. And I'm really excited that Walter and Didi have gone all the way, thousands of kilometers, to share the really deep insight on the scientific side of why this makes sense, not only at the farm level for the soils, but as a global ecosystem and the planet. So thank you again so much, Walter and Didi. I think your being here is a testimony that something really interesting and exciting is happening here in Andhra Pradesh. We still have to understand all the ramifications of it, and I think as FAO we're really excited to go deeper into the science. Why? You've all seen that certain things work and farmers' fields on your own farms. Why? Do we fully understand? I think we don't. But I think Walter and Didi are coming with fantastic insights from their many decades of experience. So again, thank you to them, and thanks to all of you for coming today. This is really nice to see you, and I look forward to a great day of discussions.
Thank you, Anne-Sophie. Now my pleasure to welcome Didi. And she'll be talking on soil sponge, connecting the dots between soil health and public health.
I've been seeing here over the last few days, and what I've been hearing for a while from Vijay, Kumar, from everybody who's working here, is a fantastic example of what can be done when we put the intelligence of the natural systems together with the intelligence of the human family. And I'm very excited to see the scale that this is happening here in India, especially in Andhra Pradesh. So I wanted to start with this photograph of a piece of land. This is actually in southern Africa that has been restored. And have you imagine taking your shoes off and standing on the right side? And how quickly do you want to jump over to the other side? So we know a lot of science we understand with our own bodies. We don't have to explain very much to know that the right side is going to be much hotter than the left side. And not just for us, but for the animals that live there. And it's not just under our feet, but in the air around our bodies. And it's also going to be hotter for all of the soil life that is trying to build a functional soil sponge, functional topsoil. You can also imagine that if you poured a glass of water on the right side, it would evaporate much more quickly. It would be gone into the air. So we understand this science with our bodies. There are many, many other questions we can ask with this photo, but let's look at some more pictures. So first I just wanted to introduce you to my own watershed. I come from Vermont in the northeast United States, and this is the Umpumpanoosuc River. It's an indigenous name of the river. And so clean that we can swim in there. We're very lucky. Next one. This is in the autumn there where the vegetation turns red. And winter, in which we have a lot of snow in the winter. My sons are playing there. And we have a game we like to throw snowballs and see if we can break the ice in the river. So, but in spring, it can get, as the snow melts, it gets very wild there. And one year, it got so wild that it really broke out, and we had some very big flooding. And this flooding was the thing that got me most interested in the connection between the whole landscape and water. And actually, just 2 years ago, we had another major flood. This was not not a hurricane, it didn't have a name or anything. But this is the road behind my house. I live in a small village of about 3,000 people. And I went away for the weekend, and when I came back, this is what it looked like, the same road. And we live in a small town, and not very many people to pay for repairs. So it's taken 2 years and over $1 million spread out among 3,000 people to repair that road. And it's just now been repaired this summer. Next slide. Just north of me in our state capital, where my sons live, it looks like a very beautiful, lush, green agricultural land, and we have a huge lake there. But if you go close to the lake, it looks like this. This is an algae bloom. And what we know is this is very, very toxic. If a dog drinks out of that lake, it will die. If humans go swimming there or drink it, we get a lot of liver problems, a lot of other issues. And we also are finding out that it's creating long-term neurological problems. So things like ALS, which is a long-term neurological issue, or Parkinson's, Alzheimer's, may be connected to this water that has this bloom in it. So as I started to understand all of these things, I thought the best way to learn is to turn around and teach. And I know that this is part of the FFS model and part of the ZBNF model. And when I learned about both of these models, I felt right at home. And so I created a manual a few years back that is geared for people who want to learn and teach, but it was also a way for me to learn, was to write this manual. I used to be a healthcare provider, natural medicine, and for me this connection between soil and water is very intricately connected to human health and to the health of the whole ecosystem. Next slide. So the essential piece that I want you to understand today, only one thing to take away, is that healthy soil is like a sponge. It's a living matrix, like very complex, and it soaks up water. So these are just words, but let's try it with a picture. So this I developed because I needed to teach people for 5-year-olds and people on Wall Street, businessmen, and people at the UN, people from very different backgrounds, and I needed one way to show this very quickly and easily. So I talk about the difference between healthy soil and unhealthy soil as a difference between flour and bread. So let's go to the next one. This one has you can play a little bit. The next one? Yeah, down below there should be no? Okay. Oh. All right. I don't know if down under has a plate of flour and bread. This is a video that. Yeah. So I'll ask you just to imagine. We'll go back one to the other one. That when you have a plate of flour, and you can show it in a moment, that if you rain on that flour, the pieces are all separate, right? And if you put water on it, the water is going to go sideways, not downhill. And it's going to take some of that soil with it, and it's going to bring it into the river. Sorry, I had a video, but it's not working on there.
Video is not playing.
Yeah.
She will be demonstrating.
So let's talk a little bit about when we say the flour. It's small individual particles, and that's if we're talking about a soil or landscape, those are the broken down rocks, just little pieces of sand, silt, and clay. But there is no biology, nothing living to hold those together. But if you take that sand, silt, and clay, those broken down rocks, and you add biology has glues and threads and things that move through there that suddenly make something that has structural integrity. that will not fall apart if you blow on it, or if you put water on it, it will stay together. Great. Okay.
Maybe one, we have a couple more pieces. Yeah? Okay, let's do this one first.
Okay. So this is our uncooked soil. You're going to be the cloud, and you are going to be the rain god. Okay? What is the rain god called? Okay. So, watch what's happening to the land there. We have a mudslide. We keep going. More. Okay, we have some flooding happening here. We have erosion. If we had a house on top of there, the house might be sliding down the hill. Okay, that's good. And is that water going down to the plant roots? No, they're not getting any of that water. It's going sideways. It's not going down. Yes. Okay. I see you got it. Okay. Good. And
You can also stand up if you want.
yes, you can have those or they can show you. So you can move that on the side, and underneath it's completely dry. If you had a plant in there, there's no water going to the roots. And of course, if you left that out into the sun, it's going to bake it into like a very hard crust. So the next time that it rains, it's even worse. So it's more problems each time. It's turning like a glue, right? Okay, so to turn flour into bread, we add yeast, right? Some kind of yeast. Sometimes it's from the air, sometimes it's from a package. But we add biology. And suddenly we have something quite different. All of those little pieces are now stuck together in a matrix. If the wind comes, nothing bad happens, right? It doesn't go into the air. And if water comes, if rain comes, what happens? So instead of going sideways and falling apart, it's now going in. It's going down. You know the water table that we talked about in the very first talk? That water table is coming up. The bore wells are filling up. The ponds are filling up. Keep going. Oh, yeah. And you know you can even take the cup aside and pour directly. But if you have the monsoon comes, even then it's been filled. Okay? Okay? Now, after a little while, the water is going down in and it's coming out the bottom. That's filling up the wells. And when it comes out the bottom, it's clean. It's been filtered through there. It's been filtered by that physical filter, but it's also filtered by biology. The biology is breaking down and any chemicals, anything that's problematic. So that's not going into the water anymore. Okay, if you build your house there, it's safe. Okay, and the plant roots underneath here, it's wet all the way down. That's a reservoir that's protected. So nobody can steal that water from you. And it's protected. If the sun comes out, it's not going to evaporate. It's very slowly evaporating only through the plants. But it's not coming right off the surface. And it doesn't form a crust. So the next time the rain comes, it's still very open. And who has made that sponge? Can a human being make that? A human being cannot make that. Only a living system can make that, and it takes everybody. Humans too. Because humans' responsibility is not to destroy it. Okay, the first thing that happens is the plant roots are feeding some sugars down into the microbes, and then those microbes are making ooze and slimes. You know, we all have ooze and slimes that come out of our body, even the microbes. And they stick those pieces together, and the little root hairs and the fungal hyphae tie them together like a thread, just like we make clothes. And then all of the life starts to move through there. So the worms, the beetles, I don't know which animals you have that move through the soil there, but everything is making passageways through there. But as they make those passageways, it doesn't fall apart. It stays intact. Okay, you got it. Okay, next slide. Okay, so this is what it looks like up close. This is taken by a friend. This photograph is taken by a friend of Walter's. Yeah. So this is taken by a friend of Walter's. This is a close-up picture of the soil sponge. You can see those little pieces, but you can also see that something is pulling them together, and there is space in between, and that space in between is essential. So I like to say that this space is like a sacred space. Walter says it's like a cathedral. It says that it's not the structure, it's the fact that things can move through there, that air and water can move through there. Next one. And this structural integrity, we can see it that on the left side we have unhealthy soil, and on the right we have healthy soil. And even if you leave this for the whole day, on the right side, those glues are very strong and they'll stay intact. Next one. We can measure that. One simple way of measuring it is to put something in the ground, pour water in, and to keep track of how long does it take the water to go down. So if it's unhealthy soil, it might be an hour for an inch of water to go down. Healthy soil, it might be just a few seconds for it to go down. This is an example with 5 soils they're all the same soil type. So they have the same ratio of sand, silt, and clay, but they have been farmed in different ways. So on the far left is very much like ZBNF. On the far left we have green growth all year round, we have no disturbance, and we have diversity. And in this case we also have animals in the system. And we have not plowed it or tilled it. Okay, and on the far right we have more conventional, a lot of inputs, a lot of tillage, monocrop, and only a crop during the most productive growing season, and bare the rest of the time. And underneath you can see that there are some bottles. I don't know if we can turn off the light for a moment to see this a little more clearly. So on the bottom there's a bottle that's collecting what's going in, but in the front is collecting the rain that's coming off. Yeah, great. So in the healthy one, you can see that all of the rain went down into the water table, into the wells, filling it up, and it's clean, and nothing has come to the front. And on the far right, you can see that no water went in. None of the rain soaked in. It all came off the front, and it took a lot of soil with it. And in between, you can see the transition from conventional green revolution type farming over to something more like ZPNF. And you can see it gets better and better and better with each thing that you add to the system. Okay, so next one. So soil is very much like a human body, and there are things that we can do to keep it healthy. So one thing is that we keep those living roots in the ground as long as possible. So they're feeding the life through the sugars that they make. They're feeding it underground. We also need to keep the surface protected with plants and mulch. So we have living plants, and we also have plants that are in the process of dying and decomposing. And those feed 2 different types of communities, of underground communities. And also the mulch protects from the rain. We need to disturb the soils as little as possible, so preferably to eliminate all of the plowing and tillage. Very important, a diversity of plants, and that diversity of plants brings with it a diversity of insects, of animals, of other things that are eating the plants. And most of the insects are actually beneficial insects. There are almost 2,000 beneficials for 1 pest. So you need to be very thoughtful. If you apply an insecticide, you're killing everybody. So who has food first? The veg insects. Vijay taught me this, the way of thinking about it. The ones that eat the plants have food, so they're going to come first. Then later the other ones will come to eat them. But if you keep applying insecticide, you're only going to be feeding more and more plants to those insects. And then this one, I think, is in ZBNF. You're seeing this with the application of the formulas that you're using with dung and urine. But in some other systems, we're actually bringing animals into the system. And so those are both different ways of integrating animals. So again, in this one, there are animals on both sides of the system. These are grazing systems. And this is a fence down the middle. And on the right side, the animals are allowed to go wherever they want to go. And just like you, if you were in the supermarket and you're in the market and you had lots of time, you would only pick your favorite foods. But if you were moved through quickly, you would eat everything and you would run, right? So on the left side, we're moving the animals much more quickly and more close together, much more the way they would be in the wild. And that way, everything gets evenly eaten, and you have a long period of rest, and suddenly you see a lot of change there. On the right side, they eat only the favorite ones, and then the ones that are more bitter, that don't taste so good, that are prickly, those ones grow and they shade out the other, and soon you have a desert. Next one. So Walter will talk maybe a little bit more about this, but this capacity of life, of plants, to break down rocks and turn them back into a living soil started with these lichen, which are growing on everything. Next one. And then the photosynthesis happens in all different layers. Next one. And it's feeding so many different things above and below the soil. So we have this whole soil food web. It's a whole ecology. Next one. And of course it's feeding things that live above the ground. And it's creating food for humans. And in Vermont, we have these amazing animals. I don't know if you have in India, beavers? No? So they take the trees and they cut them down and they build dams to slow the water. So here you might have to do it yourself. But we're talking very small dams. And that slows the water and sinks it and builds up beautiful soils. And so, but this is happening with beavers, it's happening with humans, often on much too large of a scale, but it also happens underground. So underground, this soil sponge helps to sink the water and keep it in the ground rather than going too quickly across. And this is the circle of life, all the way around. Okay, then we start to get the whole thing working. And even though I know that you have a lot of bare rocks out there, which we have also in Vermont because we overgrazed too much, life offers us a lot of hope. So we can see trees growing on bare rocks. And there's this quote that life is the most powerful geological force. So you see how a tree and a plant of any size can break open a rock. And the biology underground can do that too. That's why you don't need to add fertilizer, because all of those minerals are in the rocks. But if you have biology that can access that and break it down and bring it back to the plant, then you don't need to access it. You don't need to add it. Okay, next one. So just to wrapping it up, why should we care about this soil sponge? So this is a plant health pyramid by one of our farmers in the United States, who's showing that that photosynthesis creates certain benefits, just having very effective photosynthesis. But to get these greater benefits, you have to have active soil biology. And on the right-hand side, it's a little hard to read here, but you'll see that a generally healthy photosynthesis, enough sunlight, enough water, etc., a plant can start to protect itself against, for example, the fungal pathogens. so those fungal diseases. But when you start getting all of the nutrients that are needed that the biology creates, then it's protected against airborne fungal diseases, not just the ones in the soil. And it starts to be protected against different kinds of beetles and different kinds of worms and things that are eating at it. And all of these benefits are transferred from the plants to the animals, to the humans. So when we have a healthy soil, we're having much healthier plants, much more resistance to disease, but also our own bodies have more resistance to insects, to fungal pathogens, to bacteria, to anything that would create a disease, to viruses. So, and that's all coming from the nutrition from the soil, from that active biology. We also have flood protection. We saw that with the plate of flour and bread. But here's an example in a real landscape in Canada. 2014, we had a flood. And all of the fields that were monocropped had terrible flooding, and they had no crop that year. Everything was rotting in the field. The water was just sitting there, and everybody was trying to get the water off of the land so they could replant, and then the neighbor would get mad. And then the next one. And then in the place where they had more of a perennial polycrop, the river didn't even flood, and the water soaked into the ground. With a healthy soil sponge, we have clean water. This is actually where you can see that algae bloom in the ocean, and you can see the dividing line there. It's spreading out further and further and further from these rivers that are coming in and bringing all of those nutrients from the farms. Clean air, we know this is a big concern both here and in the States. The soil blowing in the air, not only is it hard just itself for the lungs, but it can carry a lot of pathogens with it. It can carry antibiotic-resistant bacteria and special things that come from the soil that we should not be breathing. Okay, and then this is now getting into more of what Walter is going to focus on, cooling. So this is in Fahrenheit, but Vijay, can you read those and maybe translate them a little bit?
107.4, so 87.6 degrees Fahrenheit. So
Same day, same time.
So 20 degrees difference.
Okay, so one side has the cooling from the plant cover, but it also has cooling from the soil moisture underneath and from the transpiration. So we have shade, we have transpiration, which cools the plant, and we have soil moisture underneath. So all three of those combine to make a much, much cooler environment. Okay, next one. Biodiversity. Yeah. So when we have a diverse landscape, we have more diversity, and we are learning more and more and more that both psychologically and physically, we depend on a diverse landscape. We know that children and adults need to be able to see diverse animals, insects, butterflies, plants, in order to feel whole, because we're part of that whole system. Next one. And here's another example of regenerating a landscape that's been degraded. This is in Zimbabwe, and I think that's 2006.
Yeah.
Okay, that's a before picture. They have circled that just to show you that it's the same spot. 2009, after this bringing in animals to act like as if they were a wild herd of animals, and 2014. It's a little bit unfair because the original picture is in the dry season and this is after the rainy season, but you know that that first one would not look like that after the rainy season. So, okay, and then cooling not just of the soil under our feet, but of the local climate. So the difference, the average difference from a bare soil to a green soil in the air above, up here, is usually somewhere between, the average difference is 2.3 degrees centigrade. And if you compare green landscape with pavement, it's 11.7 degrees cooler. But in order to have that, you have to have water at the root zone to have that green transpiration happen. It's like sweating. When the plant transpires, just like if your shirt is wet or you're sweating, it cools you off. Same kind of idea. But if you don't drink water, you can't sweat. And if a plant has no water under its roots, it cannot transpire. So we need that sponge. Okay, and then on a global level, Mr. Jehne has calculated that as little as a 5% increase in transpiration could be enough to quickly cool the climate. Okay, this is in theory. There's other things acting, but another professor who wrote the textbook on environmental biophysics kept going with those calculations and said 23 increase in green growth or in transpiration on agricultural soil could be enough to reverse climate change. This is huge. This is a huge, important thing. So this ZBNF initiative of having green 365 days a year is a huge, huge contribution to reversing climate change. Okay, so soil biology creates this infrastructure, this soil sponge infrastructure that provides economic benefits, social benefits, health benefits, prevention of natural disasters, all of these interesting, important things. So which infrastructure are we going to spend our money and time repairing? This one? Or this one? Okay. So, thank you very much.
Thank you, Edie, for a fascinating lecture that enables us to transit to Walter's lecture. But we'll have a tea break now, about 15 minutes. Please come back, and I also request you to come back to keep your phone switched off, no disturbance, and also not many doors opening, closing. Yeah? Okay. So break for 15 minutes, and we also need to rearrange these things here.
పాయింటర్ వాళ్ళకి ఏమైనా కావాలి లేదు సార్ అవునా సార్ కొత్త అనేది మన దాంట్లో ఇంకా చేయలేదు అంటే అన్నీ ఒక ఫోటోలో యా అందరు అంటే పోస్ట్లో అన్ని ప్రజెంటేషన్స్ అయిన తర్వాత నేను ఫోటోలో పెట్టేస్తా. అంటే ఇప్పుడు చెప్పిన సాటిస్ఫై అవుతాడు చేసుకున్న సార్ అంటే సాటిస్ఫై ఇప్పుడు చెప్పిన ఒక్కటే చెప్పలేదు ఫోటో పెట్టుకోవాలి డేట్ పెట్టేసి ఫస్ట్ 17 నవంబర్ NOV 2019 PPTs సార్ సార్ ప్రవీణ్ అది మీరు చెప్పమంటారు కొంచెం గ్యాప్ వచ్చింది ప్రోగ్రాంలో నేనేం ఆపలేదు ప్రోగ్రాంలో గ్యాప్ వచ్చింది ఇప్పుడు మనకు స్టార్టింగ్ 11.3 ఉంది కదా, 11.3 అది డ్రాపింగ్ ఆటో అడ్జస్ట్మెంట్. 11.3కి మళ్ళీ అంటే ఇది చూడమంటారు కదా సైడ్కి, ఇది ఎన్కోడింగ్ లాగింగ్ దాంట్లో 11 గంటల 3 నిమిషాలకు పోయింది. మరి లైవ్ కెమెరా బ్రేక్ చేసినారు, స్టాప్ చేస్తారు.